Hello friends, in today's video, let us derive the equation of magnetic field of a moving point charge. In the last class, we derived the equation of electric field due to the moving point charge. Now we will look into the equation for magnetic field of such a charge. So we have already derived the equations of vector and scalar potentials due to a moving point charge. They are given by the Lienard-Wiechert potentials, and the equations are given by vector A equal to V bar divided by C into V of R bar comma T. Here V bar is the velocity of the moving point charge, C is the velocity of light, and V is the scalar potential. So the scalar potential is given by V of R bar comma T equal to 1 by 4 pi epsilon 0 QC divided by RC minus R bar dot V bar. Q is the charge, R is the vector, R bar is the vector connecting the charge and the point where the potential is measured. So let us use these equations, Lienard-Wiechert potentials, in order to find the magnetic field of a moving point charge. We know, if we happen to know the vector potential, we can calculate the magnetic field from the equation B bar equal to del cross A bar. So here we have the vector potential, equation of vector potential here. So let us use B bar equal to del cross A bar in order to find the magnetic field. So we have magnetic field equal to del cross A, which is equal to 1 by C square into del cross of V bar into V. Here V bar is the velocity and V is the scalar potential. Now we know this this del cross, the curl, actually we need to apply some product rule here. This is of the form del cross a scalar function into a vector. So its expansion is given by 1 by C square into V into del cross V bar minus V bar into V bar cross del V. Now we need to substitute for each of these terms. We have to find del cross V bar, we have to find del V. So please go through the derivation of electric field of a moving point charge. There in equation 8c we had derived the equation for del cross V bar, and that was found to be equal to minus A bar into minus A bar cross del TR, and the equation of del TR was also found in that derivation. It was found to be equal to del TR is equal to minus R bar divided by RC minus R bar dot V bar. Similarly, in the derivation of electric field due to a moving point charge, we had find the equation of del V. So let us simply use that equation. We had found that del V is equal to QC divided by 4 pi epsilon 0 1 by RC minus R bar dot V bar the whole cube multiplied by RC minus R bar dot V bar into V bar minus C square minus V square plus R bar dot A bar into R bar. So this was the equation of del V as found in the derivation of electric field due to a moving point charge. So let us simply substitute this del V and the equation for del cross V as well as the equation of del TR into the equation number 1. So we can find magnetic field B to be equal to 1 by C square into 1 by 4 pi epsilon 0 QC divided by RC minus R bar dot V bar, which is simply the scalar potential. First we have to substitute for the scalar potential V, and that V is substituted here. Now we need to substitute for del cross V. So that is equal to minus A bar cross del TR. Del TR is minus R bar divided by RC minus R bar dot V bar. So this is the first term. Now in the second term we have V bar cross del V. So we can write minus V bar cross the equation of del V, which is QC divided by 4 pi epsilon 0 into 1 by RC minus R bar dot V bar the whole cube into RC minus R bar dot V bar into V bar minus C square minus V square plus R bar dot A bar into R bar. So this is the equation for magnetic field. So let us simplify this equation. First, let us take some terms as common. We can see that QC by 4 pi epsilon 0 into RC minus R bar dot V bar the whole cube comes here, and here RC minus R bar dot V bar whole square comes in the first term. So let us take that term as common. So this is equal to, before moving on to that, we know RC minus R bar dot V bar, as mentioned in the previous derivation, it is equal to R bar dot U bar, where we had defined that U bar is a vector given by C R cap minus V bar, where V is the velocity of the moving charge. So if we define U bar as in this equation, we can write RC minus R bar dot V bar to be equal to R bar dot U bar. So in different terms here, wherever RC minus R bar dot V bar comes, we can substitute R bar dot U bar. And we will also be taking QC by 4 pi epsilon 0 divided by RC minus R bar dot V bar or R bar dot U bar the whole cube as common. So let us see that. So the magnetic field is given by 1 by C square into QC divided by 4 pi epsilon 0 into 1 by R bar dot U bar the whole cube multiplied by, in the numerator, here we have A bar cross R bar. In the denominator, in the first term we had only R bar dot U bar the whole square, but we had taken R bar dot U bar the whole cube as common. So we should have multiplied both the denominator and the numerator with an additional R bar dot U bar in this term itself. Then only we will be able to take R bar dot U bar the whole cube as common. So in the numerator, after taking that common, we will have one additional term, which is R bar dot U bar. So the first term after taking this common will be like this: QC by 4 pi epsilon 0 into R bar dot U bar the whole cube is common. In the numerator we are left with A bar cross R bar multiplied by R bar dot U bar as the term. Now coming to the second term, in the second term we have V bar cross R bar dot U bar multiplied by V bar minus C square minus V square plus R bar dot A bar multiplied by R bar as the remaining term. So this is the simplified form of magnetic field. Here we have taken this term as the common. Now let us expand the terms inside this bracket. So in the first term, we have this is equal to 1 by c square into qc by 4 pi epsilon 0 into 1 by r bar dot u bar the whole cube into a bar cross r bar into r bar dot u bar, which is the first term. Now in the second term, we have v bar cross v bar in the first term. R bar dot u bar is like a scalar term. So we will have to take v bar cross v bar, which is simply 0. Now here we have minus of minus, which is plus v bar cross r bar into the terms inside the bracket, which is c square minus v square plus r bar dot a bar. Now we know in the terms inside the bracket we have cross r bar as common, right? Here we have to take a bar cross r bar and here we have to take v bar cross r bar. So we can take this cross product of r bar as a common term outside. So this is equal to 1 by c square into qc by 4 pi epsilon 0 into 1 by r bar dot u bar the whole cube into r bar dot u bar multiplied by a bar plus v bar into c square minus p square plus r bar dot a bar. Now multiply or take the cross product with r bar with all these terms. So we have a bar cross r bar as well as v bar cross r bar as operations in these terms, which is same as the previous term. Now we can actually rearrange this cross product. We know if a cross b is known, it is actually equal to minus of b bar cross a bar, right? So let us take this cross r bar to the left hand side. Then we will have to add a negative sign. So let us do that. I am going to write this term as r bar cross these terms. So I will have to add an additional negative sign here. So it is minus 1 by c square qc divided by 4 pi epsilon 0 r bar cross divided by r bar dot u bar the whole cube. The terms r bar dot u bar into a bar plus I am going to split these terms. It is c square minus p square into v bar plus r bar dot a bar into v bar. So this is the equation for the magnetic field due to a moving point charge. So if you compare this equation with the equation of the electric field of a moving point charge, which was obtained as E bar is equal to qc by 4 pi epsilon 0 r divided by r bar dot u bar the whole cube multiplied by sorry, there is no c here. It is simply q by 4 pi epsilon 0 into r divided by r bar dot u bar the whole cube into c square minus v square into u bar plus r bar dot a bar into u bar minus r bar dot u bar into a bar. So this was the equation of electric field. Now if we look into the equation of magnetic field, many of the terms matches, right? We have some similarity here in this part. Here we have c square minus v square into v bar. Here we have c square minus v square into u bar. Here we have r bar dot a bar into v bar. Here we have r bar dot a bar into u bar. Here we have r bar dot u bar into a bar. So here we have the same term. So let us try to reformulate the equation of magnetic field to suit the equation of electric field. For that, we have to take we have to understand one thing. So in this equation of magnetic field, finally these terms inside the brackets we are taking a cross product of r bar cross the terms inside these brackets. So we have r bar cross v bar here, and r bar cross v bar here, and r bar cross a bar here. So when we take r bar cross v bar, and if we take r bar cross u bar, we know r bar cross u bar is r bar cross c r cap minus v bar. Now r bar cross c r cap will be 0 because both are vectors in same direction. The unit vector along r bar is r cap. So the first term will be 0 and the second term is minus r bar cross v bar. So r bar cross u bar is negative of r bar cross v bar. So inside the equation of magnetic field, if we replace v bar with minus u bar, then the equation will not have any change, because after all we are taking the cross product with r bar, and the r bar cross v bar, its negative is simply r bar cross u bar. So you can replace v bar with minus u bar in the equation of magnetic field. So here in this term, this v bar will be replaced by minus u bar, and this v bar will be replaced by minus u bar. So let us do that. So the equation of magnetic field can be written as v bar equal to minus 1 by c square into qc by 4 pi epsilon 0 into 1 by r bar dot u bar the whole cube into r bar cross r bar dot u bar into a bar minus c square minus p square into u bar minus r bar dot a bar into u bar. Now let us take this negative signs to the inside of bracket. So this is simply 1 by c into q divided by 4 pi epsilon 0 into 1 by r bar dot u bar the whole cube into r bar will be r cap, right, cross c square minus v square into u bar, this term with the negative sign removed, plus r bar dot a bar into u bar minus, or let me write it like u bar dot u bar into r bar dot a bar minus a bar into r bar dot u bar. So now in the last two terms we can see a back cap rule here. So if we take these as r bar as a, u bar as b and a bar as c, this is simply the back cap rule that is being applied here. So you can simplify this to be equal to 1 by c into q by 4 pi epsilon 0 r divided by r bar dot u bar the whole cube into r cap cross c square minus v square into u bar plus r bar cross u bar cross a bar. So this is the final equation for the magnetic field of a moving point charge. So this equation has a lot of similarity with the equation of the electric field due to a moving point charge. So you can simply see that the additional terms that are appearing are, here we have a 1 by c, and finally we are taking a cross product with r cap. All the other terms are simply the equation of electric field of a moving point charge. So I can write magnetic field B bar to be equal to 1 by c into r cap cross the electric field of the moving point charge. So we can understand a lot from this equation. We can see that the magnetic field and electric field are related of a moving point charge, and the magnitude of the magnetic field is 1 by c of the magnitude of the electric field. So if we take the magnitude B, we can simply write E by C. Now we can see that we have to take a cross product. So obviously electric field and magnetic field will be mutually perpendicular to each other, and both will be perpendicular to the and magnetic field will be perpendicular to r cap as well. So we can see that what is r cap? R cap is the vector connecting the point charge and the point where we are measuring the magnetic field. It is the direction of that vector. So magnetic field will be perpendicular to that direction, and the magnetic field will be perpendicular to the direction of electric field as well. So its magnitude will be 1 by C of the electric field. So these are the basic concepts that we will be getting from this equation. Now I hope that this derivation is clear for you. In this derivation we have used the equations of Lienard-Wiechert potentials in order to obtain the equation of magnetic field of a moving point charge. Thank you.